Welcome back, ladies and gentlemen. This is Mr. Smith, and this is 5.5 Parallel Lines and Angles. So, here I have you measuring each angle and in the diagram with the protractor. It doesn't work super well, so just bear with me while I work through this. In this case, I already have it lined up somewhat. It is a little tricky to get it perfect, just because this protractor is a little bit glitchy on this program. However, I will say that this lines up, and it looks like it lines up directly at 75. So we're going to say this is 75 degrees. So from here to here, I would say this is 75 degrees. Okay. And if I look at the protractor from here all the way over and around, I use the outer numbers for this. It'd be 105 over here. So this is 105 degrees. Now I need to rotate this around, and hopefully, oh, it's a little glitchy. And we'll say that is close enough, because otherwise it will not work that well. Okay, so from here all the way to here, it's again 75 degrees. So this will be 75 degrees. And then if we use the outer line, 0 all the way to 105. So this will be 105 here degrees. Okay, we aren't done though, because we have 4 more angles, and I'm going to keep it rotated around here. Try to line it up as best I can. Looks like it's rotated just a little bit outside. Okay. So it lines up again. If I go from the outside down, looks like it's 105 here. So we'll say this is 105. Then we go the opposite way, so we start at 0 in the interior numbers. It lines up to about 75 degrees. So we'll say this is 75 degrees. And then I have to rotate this around, so just bear with me while I do this, because I have to try and match the angle it was before. Right about there. And then I'll have to move it right about there. Okay. So it's a little bit difficult to see or read with all the ink in front of it, but if I go from 0 all the way up to here, I'm using the interior number, so I'm at 70, halfway between 70 and 80, so that's 75 for here. So that's 75 degrees. Then from here all the way up to here, it's 105, because I use the outer lines. It's 100, halfway between 100 and 110. I would say this is 105 here degrees. Okay, if I remove this protractor now, you might see a bit of a pattern. There's actually a few patterns in here, and that's what we're going to discuss today. So what I'm going to do is I'm going to go on to the next slide here, and we're going to talk about the different patterns of parallel lines and angles. So we have 3 different rules. For the Z pattern, there's 2 different designs that you'll kind of see. And they're just different little variations on them. And to highlight this, I actually have a blue highlighter selected. Then I'll switch over to a pen and explain what the rule is. So the Z pattern that you might notice is this right here. Alternatively, the other direction you might notice the Z pattern would be like this. It kind of looks more like an S, but we call it the Z pattern, and that's pretty standard among math teachers and math courses. This is recognized as the Z pattern. Switch back over to my pen. Okay, and the reason why is because this angle and this angle, or this angle and this angle over here, are equal, and hence the Z pattern. Now, the next pattern we're going to look at is called the F pattern, and the F pattern also has equal shapes, or equal angles. So to see this, I'm going to use my highlighter again. And there's a few different ways we can draw this. So now I have my highlighter. I start going up this way, and then like this. It just looks like the letter F. I could do backwards and upside down. You could do just upside down, but not reversed. Or you could do just backwards here. And those are your F patterns. Now, the reason why they are equal, if I switch back over to my pen, I can show you this. When I say they're equal, I mean this angle and this angle are equal. This angle and this angle are equal. This angle and this angle are equal, as well as this angle and this angle are equal. So the corners that are contained within the letter F that you see in that pattern. Okay, the next one is co-interior angles, also known as the C pattern. So these, instead of being equal, it looks like a C, but they're not equal. They add up to 180 degrees. So they add to 180 degrees. So my C pattern looks something like this. So there's a C. And then the other C pattern will look like this. Now the C pattern is very similar to the F pattern, except the angles that we're dealing with, if I grab my pen here, are this one and this one. It's the interior. So this one and this one. Those will add up to 180 degrees. Now this works in tandem with the supplementary angle theorem that we've learned about already. Now, if I go to the next slide, we'll actually see this in action. So here, we need to find our unknown angles and justify our answers. Well, if you recall, we had an X pattern, or our opposite angle theorem. So what's opposite of 120? Well, D is. So then D is equal to 120 because of opposite angle theorem. If we look at 120 and A, we notice that that forms a straight line. So it's actually our supplementary angle theorem. Or you could say it's your C pattern. A is 60 degrees because of our supplementary angle theorem. Now, to solve for B, you could either use the C pattern like so, where A plus B equals 180, or you could use the F pattern because you have the F pattern here. So you would have B equals 120 degrees. And you could say that that's the F pattern. And finally, we have C, which would also be 60 degrees. And there's multiple ways you could say this. You could say supplementary angle theorem. You could also justify this by saying it's the F pattern. And you'll find that there's more than one way to do these questions. So try not to get overly confused with them. There is a lot to take in, but it is pretty straightforward. Okay, let's move on to the next example. There's a lot going on here, and we can't exactly figure it out just by looking yet. A, B, and D we can't solve by just looking at. But we can solve C using the X pattern or opposite angle theorem. So C is actually going to equal 45 because it's the opposite of that X. So OAT is our opposite angle theorem. If we know C, then we know B because of our Z pattern. So B is going to equal 45 degrees because of our Z pattern. Now, if we know B and we know 50 degrees, we can figure out A now because A is going to be 180 minus 50 minus 45, because that's our supplementary angle theorem, right? It's a straight line. A 50 degrees and B will be one straight line. So that means that A equals 180, subtract 50, subtract 45, which just equals 85 degrees. Then, because we have a Z pattern with A and D, we know D is going to equal 85 degrees. Perfect. All right, next example. In our next example here, we can't see everything quite yet. We do see an F pattern though, so we can figure out what B is, because there's an F pattern right along here, here, here. That means that B is 90 degrees. We also have another F pattern here, which means that C is going to be 55 degrees. Which then can help us with solving D, because D and C add up to 180 because it makes a straight line. So D equals 180 subtract whatever C was, which was 55, which equals 125 degrees because of our supplementary angle theorem. Okay, same idea with A. Because our interior angles of a triangle, we have B, C, and A. They should all add up to 180 degrees, but we know what B and C are, then we can solve for A. So we know that A is going to equal 180, subtract whatever B is, which is 90, subtract C, which is 55, which means that A should be 35 degrees. Perfect. So we used two patterns. We used our supplementary angle theorem, and then we used our interior, sum of interior angles inside a triangle theorem to solve this question. So you kind of get everything thrown at you all at once that you've already seen. All right, let's go on to the next questions. In our next question, it is a little bit more straightforward, but with a bit of algebra. Luckily, you guys have done lots of algebra, so you should be fine for this. We see that this is a Z pattern here, which means that this angle here and this angle over here are equal. So we know 2x plus 15 is going to equal 3x minus 10. Then you just need to solve for x. Well, to do this, we can move the 10 over and then move the 2x over. So we're stuck with 15 plus 10 and then 3x minus 2x. So we'll end up with a single x over here, and we'll have 25 over here. Done. So you get 25 equals x. And your justification would be a Z pattern. Next, we have the C pattern. And if we go back to our first page, we can look at all of our patterns. In the C pattern, it's the only one that doesn't have the same angle theorem, or the same angle. Instead, the angles add up to 180 degrees. So that means that these two angles are going to add up to 180 degrees. So we'll have 5x plus 20 plus 7x plus 40 will equal 180 degrees. So now we need to collect like terms and then simplify. If I am collecting like terms, I have 5x and 7x, so I get 12x. 20 plus 40 gives me 60. Then we're going to move the 60 over. We'll get 12x equals 180. Subtract 60. So we'll get 12x equals 120. Divide both sides by 12, and you'll get x equals 12. Or x equals 10. Not 12, because 120 divided by 12 gives you 10. There we go. 10 degrees. And your justification here would be the C pattern. All right, if you have any other questions, make sure you ask, and hopefully you can work through the practice. I would strongly recommend working through the practice before doing the quiz on all of these, but especially this lesson, because this lesson is a little bit tricky if you don't see it at first. But once you get through it, it actually makes a lot more sense, and it's going to make your life a lot easier when you go into grade 10 math specifically. All right, best of luck.